of a binomial, the term we use the compact form. Okay, just as a reminder, x plus y to the power n is equal to the sum from I equal to 0 up to n of n choose I, then x to the power n minus y, then y to the power I. Okay? So now when we look at the compact form, let us just look at, we only use n choose I, then x to the power n minus I, y to the power I. So in our case, x is a and y is negative b. Don't forget this, okay? And, okay, so the and has come to a. X is a, y is b, and n is 9, okay? So, yes, what's her name? Vanessa.
Can't see the screen.
But if others can see, it means that it's your device which has an issue. You refresh your device. So if everyone else can see and you can't see, then it is your device. Yes,
I can
Simon.
now see.
Oh, all right. It was the same issue here.
But then I've already guided you on this issue. You check with your friends, even in the group. Can you see the screen? If others can see, then it is your device. Okay, so now I've even forgotten what I wanted to write. So we have 12, choose I, a to the power 12 minus I, then negative b to the power I. Okay, so now where is the a? Here, the a is this one here. So we focus on the a. We focus on this one here. Okay, we want the power to be 3. So what value of I can make the power 3? That's a question you're asking. So 12 minus I must be equal to, oh, not 12. It's, my apologies. It's 9, eh? N is 9. So N is 9, sorry. It's 9, 9, okay? So even here, it is 9. So 9 minus I equal to 3. This implies I is equal to 6. So this is the term we've already written. So the term is this. So let's put where there is I, we'll put 6. Therefore, 9 choose 6. Then a raised to the power 9 minus 6 and negative b raised to the power 6 is equal to 9 choose 6 over 6 factorial multiplied by 9 minus 6 factorial, then a to the power 3 and b to the power 6, which is equal to 9 times 8 times 7 over becomes 6 factorial over 6 factorial multiplied by 3 factorial, a to the power 3, b to the power 6. So you cancel here and you cancel there. So you're going to have 84, a to the power 3, b to the power 6. Okay, questions? Yes,
Sir,
Amon? Amon?
I'm sorry, but I didn't get where the 6 came from.
Yes.
What is 9 minus I equal to 6? What is the value of I when 9 minus I is equal to 6?
It's 3.
9 minus I equal to 3 rather, here. So we got it from here. So we looked, we want this power of A to be 3. From the equation, the power of A must be 3. But here we have the power of A to be 9 minus I. So we're looking for the value of I so that this whole expression is 6. Hence we said 9 minus I is equal to 3. And then we got I is equal to 6. You see it?
No, sir.
Then you find time to go through, madam.
Okay.
Is there another question? All right. Can I go to the next page? Look at another example.
Yes, sir, we can
Yes,
proceed.
sir. Yes,
I can
sir.
proceed.
Okay, so let's look at another example. Example, find the term independent of x in x to the power 3 is 1 over x squared raised to the power 5. So I want to find the term independent of x in this expansion. Gabriel,
Oh,
so I want to find the term independent of x. So when we talk about a term which is independent of x, we are talking about something that has no x. Okay? So when we're talking about something that has no x, what could be the power of x for it not to be there?
0.
Yes, Emma?
It will be 0.
0, very good. So we are looking for, so we seek to find an I that causes this to be 0. That causes the power to be 0. So solution, I'll start first by explaining what the independent term of x is. So the phrase independent of x means the term with no x variable. Okay, that is the constant term. That's what it means. Now, like you've said, a constant is equivalent to the product of a number and x to the power 0. Since x to the power 0 is 1. Okay? So that's what we're looking at. So now let us use the compact form. So the terms in the expansion are given by n choose I, then it is n choose I. Here our n is known, okay? Let's even just write okay, let's n choose I, then x to the power 3 n minus I, then negative 1 over x squared raised to the power I. Okay, so n is known, so we have to write the expression in such a way that it will be easy to work with. So here when you have it is 5 choose I, okay? Let's say since n is 5 from the question, we're looking for 5 choose I, then x to the power. Remember, the rows of exponents, this will multiply throughout. It will be x to the power 3 multiplied by n, which is 5, minus I. Okay? Then negative x to the power 2I. Negative to the power 2. Okay, let me see if I can. Okay, to the power negative. So what we've done is we've taken the x up. So 1 over x squared is negative 1 over x squared is negative x to the power negative 2. Okay, then negative 2 multiplied by I. That's how come we have this. Are we okay up to there before we make progress? Are we okay?
Yes, sir.
Okay. So we have written it in this form. So now notice that we have x there, we have x there. So we want this whole thing to be equal to 0. Okay. So these two powers must be, this negative has no factor. So okay. We have 5 choose I, then x to the power 15 minus 3I, then x, let's see if I missed something. Okay, so here this is a mistake. There's something. Let me just stop. Am I audible?
Yes, sir.
Yes, sir.
Okay. Good. So let's delete here. Let me write it in a mathematically correct way. So this is to the power negative 2, to the power negative 2, then raised to the power I. Okay? I want to write it in a mathematically correct way. So at this point, you only focus on the powers of x, okay? So this power here, so you say, so 3 multiplied by 5 minus I, then you get negative 2I here, minus 2I must be equal to 0, okay? So this implies 15, 3I minus 2I is equal to 0, and this implies negative 5I is equal to negative 15. This implies I is equal to 3. So I is 3. So one I to be equal to 3, when you are dealing with the independent x, you only consider the coefficient. So the term independent yes, yes, Gabriel.
So there, the other x is negative. How come you got the powers for the first x and the second x? Isn't that just supposed to do when the x values are the same?
Oh, interesting. So here, your job is to just look. You want to look for a value of x such that these two will cancel out, so to speak. The value of I that will make these two. It doesn't matter the bases if this is x or negative x. Your interest is to find the value of I that make these two powers cancel out, or that makes the power equal to 0.
All right, so
So we found I to be um, to be 3 to be, and this is going to be equal to 5 factorial over 3 factorial, then 2 factorial, which will be equal to 5 times 4 times 3 factorial over 3 factorial multiplied by 2 factorial. So these two cancel out. Then here is 1, 1, this one, 2. So the answer is 10. So the answer is 10. Yes, Betty. Yes, Betty Chisolo.
Yes, I didn't understand just the one point on the part where you are making the mistake, like first to reach this stage. On this stage, I've understood, but just that error you made.
What do you mean that error I made?
The one you're like, I think there's something wrong.
No, it wasn't wrong. I was just trying to write it mathematically correct. It wasn't wrong. So, look, your target, your goal is to ensure that the powers, the side, that side, when you use 0, that should be your focus. Okay? So here, the only thing we used is the rows of exponents on both sides. So that we get the powers of this expression. Always you have this situation. You're going to have this expression here and that expression. You just ensure that you take their powers, the power of this, you add it to the power of that, they must give you 0. That is how come we came up with this.
All right, so thank you
Then
very
from
much.
here, we're able to find the value of I.
Thank you, sir.
All right. There are more hands. Go ahead with your question.
Yes, what different when we are told the value independent of x and finding the coefficient.
At what?
When you are told you to find the value independent of x and finding the coefficient.
For a term independent of x, x. Yeah, but your question means something because your question means something. I don't know if you picked it. I don't know if you picked it, but your question means something. Something very serious anyway. Yeah, it's a very good question. It's a very good question. You know what his question has led to? It has now this was so don't just go straight for the coefficient. His question is very good. Don't go straight for the coefficient. In fact, there's a stage we've skipped. Don't go straight for the coefficient. Let's do this. It's a very good question you've asked, my good friend. Okay, the answer is still negative. The answer is going to be -10 and not 10. Okay, so you go back by saying 5 choose I, because we've already found I to be 3. So it will be 5 choose 3. So this is an independent term, it's not the coefficient. 5 choose 3. Then you're going to say it will be x to the power 3. Okay, then you are going to say 5 minus 3, and then it will be negative x to the power -2 then you're going to have I to the power 3. Okay, so this is the term. This is a term. So already we've worked out that this is going to be 10. Okay, this is going to be 10. Then here we're going to have x to the power 3 multiplied, this is going to be 2. 3 multiplied by 2 to be x to the power 2. Then this one is going to be equal to negative x to the power 6. Because negative to the power 3 is negative, okay? So we're going to have negative here. Let's say negative 1. Let's put it in brackets. Then you're going to have x to the power negative 6. Okay, because we are raising this to the power negative 3. Okay, so now what will happen is that the x to the power 6 multiplied by x to the power 6 is x to the power 0, but the negative will be there. So it will be negative 10 x to the power 6 minus 6, which will be negative 10 x to the power 0, which will just be negative 10. So the step I skipped was very important. Who asked that question again? So now let me answer your question. If you've been told to find the coefficient, you still do this, but here when the term is independent of x, the coefficient disappears naturally. Okay? In fact, the next question is going to ask about the coefficient of the expansion. Okay, so the next question will answer directly to the question that you phrased. Yes, Ruben?
Sir, I didn't get the explanation. The network was just a bit shaky on the time you're talking about the independent. I didn't get it.
No, I can't go back, Ruben. It's not possible. You take the notes there. Emmanuel?
Yes, sir. On the x on the right side, I'm not sure. I didn't get how it became negative.
It was already negative from the question.
Oh, okay. Thank you, sir.
Now, sir, where did you get the negative one?
What is the negative x equal to? Isn't negative x squared the same as negative 1 multiplied by negative x squared, negative 1 multiplied by x squared? Even negative 2 is negative 1 times 2. Okay? So this was finding the independent term of x. Now, let us find the coefficient of a term. Example, find the coefficient of b to the power 6 in the expansion of in the expansion of b squared minus 1 over b raised to the power 12. I don't like the way the screen is, the way I'm writing the screen, so let me stop sharing. And that's 1 over b, then raised to the power 12. I hope you are writing. You have your book somewhere, you are seated on a table, you are writing. I hope so.
Yes, sir.
Yes, sir.
Yes,
Okay. If you say so. Solution. The terms. The terms. 12, choose I, then b squared raised to the power 12 minus I, and negative 1 over b raised to the power I. Then we can write this nicely. Which is equal to 12, choose I, then b to the power 24 minus 2I. We've multiplied there, then negative b raised to the power negative 1, then I. If you like, you can split them nicely by saying 12I, then b raised to the power 24 minus 2I, then negative 1 raised to the power I, then b raised to the power negative I. You've seen what we've done? So now we are looking for a term where b has a power 6. Okay? Where b has a power 6. So we're going to say this implies 24 minus 2I minus I. Okay, we've taken the power because it's a bill that we're interested in. Daniel, we have been done in the previous one. We've taken this power and that power because these are the only ones with B. The negative one with so this one must be equal to, okay? So this will be negative 3I is equal to negative 18. If the 24 comes the other side, is negative 18. And this implies I is equal to 6. So upon finding I to be 6, is to now come and replace here in this one to find the coefficient. So this implies the coefficient is, Ruben, your hand is up. It keeps on being up. What's the issue?
Where did you get the 6 from? Because 24 is equals to 2i plus I. Isn't it supposed to be 2i, 3i?
What are you talking about?
I'm talking about where there is 24 is equals to 2i plus 24 24 minus 2i minus 2i is equals to 0.
It's equal to 6 because the question is the b to the power 6. Have you read the question? The question is here. Find the coefficient of b to the power 6. So you're looking for the terms where b is equal to the power of b is 6.
Well, the power is 6.
So the coefficient is, so in the coefficient we are now going to put 6. So it is 12, you choose 6, then b raised to the power
So boy,
24
boy,
minus
mpaka
2,
manzi
then
kazi
where
sisi
there's
mpaka
I,
kazi
you
once.
put 6, multiply by negative 1 to the power 6, then multiply by b to the power negative negative 6. Okay, obviously we know that b will be raised to the power 6, so it is 12 choose 6. Then you're going to have b to the power 24 minus 12, that's 12. Then negative 1 to the power 6, that's positive 1. Then multiply by b to the power negative 6. So this will be 12 to 6, then b to the power 6. Then now our job is to evaluate this, which implies 12 to 6 is equal to 12 factorial over 6 factorial, 6 factorial. Okay? And this is going to be what? To be a bit tedious, eh? 12 times 11 times 10 times 9 times 8 times 7 times 6 factorial over 6 factorial, then 6 times 5 times 4 times 3 times 2 times 1. So this factorial and that one goes. This one 1, this one 2, this one 1, this one 2, this one 1, this one 2, this one 1, this one 3, this one 1, this one 1. Everything is sorted, eh? So 11 times 2 times 3 times 2 times 7. Who can tell me the answer?
924.
It's what?
924.
Someone says 924. Are we all finding the same thing?
84.
264.
It's what?
264.
11 times 2 times 3 times 2 times 7.
I'm finding 924 also. Where is the 264 coming from? 11 times 2 times 3 times 2 times 7.
9.4.
Yes,
924.
So the coefficient is 924.
Yes.
Okay. So we are going to meet tomorrow at 8 hours. And tomorrow we are now going to look at a situation where you can expand it by you're having powers instead of the positive integers we've been looking at. We have negative and rational powers. So that's what we're going to look at tomorrow. We end our class here, unless if you have questions. Okay, we end here. See you tomorrow.
Bye. Thank you.